When I was talking about the different types of wave, I talked about there being transverse and longitudinal waves. And if you recall, I said the way that you can tell if a wave is transverse is by seeing if you can polarize it. So polarization is a test for a transverse wave. So I'm going to tell you a little bit more about polarization now, so you can understand why it only applies to transverse waves. So, polarization, this is where the oscillations within a transverse wave and the direction of travel of the wave define a plane. So basically, if the wave only occupies one plane, then we can say it's plane polarized. So kind of think, when we say the direction of travel and the oscillations, what I want to think about is like a sheet of paper. So it's just oscillating up and down and it's traveling this way. If it wasn't polarized, I could have oscillations at any angle all the way around, so it would be occupying all those planes all the way around. But it's just oscillating and travelling in this direction, so it's only one plane. It's just like it's a sheet of paper. And that would be a plane polarized light, or just polarized light. So another way to look at it is, if we look at light from a lamp, it can be vibrating in any of these directions, like I just said. It then passes through what we call a polarizing filter, or a Polaroid filter, and that only lets light that's oscillating in one plane pass through. So after the filter, I have less light because it's only the light that was oscillating in the correct plane that was allowed through. And that's how we can clarify that it's transverse, because longitudinal waves, well, their vibrations are parallel to the direction of travel. So they're already in one plane, so I can't polarize them, whereas I can polarize the transverse waves. The next step from this is, if I've polarized my light by sending it through one filter, if I then put another filter that's at a different angle, so that's say at 90 degrees, what I'll find is that no light gets through, because only light that was in the same plane as the first filter gets through the first one. If the second filter is at 90 degrees, then there is absolutely no component of the light that is oscillating in the plane of this second filter. So when the filters are crossed, I end up with no light being transmitted through at all. So just some talk about uses of Polaroids. You've probably come across the idea of Polaroid sunglasses. Well, I've said that it reduces the amount of light that passes through, so that's how they're working as sunglasses. They only let light that's vibrating in one plane through, thus reducing the intensity of light that can pass through. The other thing we can do is, what often happens when light is reflected off a surface is it becomes partially polarized. So all the light that's reflected, say, off the surface of the water is polarized in the same way. If I can cut out that light but let everything else through, then I can see what's beneath the surface of the water. So that allows me to take pictures like this that let me see what's beneath the surface, so I don't just see the blue at the surface, but I can see the coral that's underneath. So that's another use for these. Another thing we can do is use it by using a Polaroid filter. We can identify where there are stresses in materials, so we can look for where the most pressure is being applied to materials to try and figure out where they're most likely to break. So those are some uses of Polaroids. In exam questions, the way you can tell it's to do with polarizing is if they talk about having a source of waves, that could be light, it could be radio, it could be microwave, and then a receiver, and either something is put between those two and rotated, or the receiver is rotated. Anything like that, and it's about polarization. And the reason for that is because it comes from Malus's law. Now this is kind of a really long-winded, wordy kind of thing, but the concept, I hope, isn't too difficult. Basically what it says is, if you know that something's been polarized, or you have a Polaroid filter, and you want to know the orientation of its polarization, what you need to do is pass light through that filter, so that it's plane polarized, then pass it through a second filter that you know the orientation of, which we call our analyzer. You rotate the analyzer until no light is allowed through, and at that point the plane of the analyzer must be 90 degrees to the plane of the first Polaroid. And that way you know therefore what the plane of the Polaroid is. So what you would expect to see as you rotate these through is, so if I've got my analyzer in there, when it's the same way as my first one, I would expect to see a maximum. I would expect to see the intensity of the waves would be at a maximum. As I rotate it, the intensity would decrease until it reached 0 when the Polaroid was at 90 degrees. And if I keep rotating, it will then increase back up to a maximum again. So that's kind of the description I might be looking for if they ask what might you observe when we do all this rotating stuff. Okay. You can also look for the maximum as well, is just what that's going to say, but it's actually easier to look for nothing than it is for a maximum, just logically. I'm sure you can figure that out. So we just need the mathematical statement of Malice's law. Basically what it says, if you do what I just said about the rotating, you find that the intensity of light is equal to the initial intensity times cos squared theta. Now, I'm going to talk in class about what cos squared theta is and how it's different to cos theta squared. So you may want to think on that and make sure you come armed and ready to discuss that. It is a really common mistake that people make, so we need to make sure that you're clear on that. Basically all this is saying is that thing about how I said where if they're lined up the same way I get maximum, so I will equal I0. When at 90 degrees I will equal 0. And then I just get the range in between using cos squared theta. Okay, right, that is it for polarisation. Short and sweet, and we will have a play with some Polaroids when I see you in class.